Okay, YouTube, in this video is kind of a quick rundown on how we can take some information about the initial and terminal point of a vector and do these things with it, which is, first of all, write it in component form, and then find its magnitude, direction, and then write it in linear combination form. So basically, it's kind of a rundown on the basic skills with vectors, and so we're going to start with this. You should always, this is just my opinion, draw a picture of the situation. And so if you have grid paper on you, that's actually even better than what I have right here. Not to say that I couldn't go over to Desmos and graph this, but I want to be very crude about it here. So we say this is, let's see, -5, comma 3. So I'll go 3, 1, 2, 3. So we have some vector here that starts at -5, comma +3, which is this point right here, and we're calling this the point P. And it's terminating at Q, which is -6, which is this guy right here, just one to the left, and then we say up 8, so 4, 5, 6, 7, 8. But essentially what we want to do is we want to take this vector, oh my goodness, let's try this a little bit better this time here. We say, okay, so let's take this vector PQ, which is this vector right here, and let's write it in component form. So one thing I want to kind of point out here is this. When we say component form, it means that you have a vector in standard position, and that's to say that it starts at the origin and terminates at one spot out in the middle of space here. So I notice that, just looking at this, it goes 1 to the left, and then from a height of 4 up to a height of 8 here, or height of 3 up to a height of 8, this goes up 5. So like left 1 up 5. I could say, well, then I've got a vector that starts here, it just goes left 1 up 5, and this is going to be its component form. It's going to have gone left 1 up 5, and so its component form is -1, 5. And this is fair to say. This is, as a matter of fact, this is the component form of the vector. And I just want everybody to know that we just found this visually, which is a good thing to do. Now what I want to do is I want to find this algebraically. And so let's consider this. Since this is our initial point, we said this is some x1, y1. And then we have some x2, y2. Recall that if you want to find the component form of this vector, it is always this. It is the change in the x values, comma the change in the y values. And those will be its components, its horizontal and vertical. So when we look at the change in the x components, we say this would be a -6 minus a -5. So we get that right there. And then over here we'd say 8 minus 3, 8 minus 3. And so I hope everybody can see here that this would become a positive here, but this would yield the same component form that we saw over here and confirm visually. So now we have this vector that is in standard position, and its components are these: vertical or horizontal component of -1, vertical component of 5. So now that we have this, we want to find its magnitude. So let's recall that given any vector in standard position, so that's to say some vector like this, there are two things that we're often on about this, but we say if this is some vector u, we want to know its magnitude. And so let's say we know the point xy on the terminal side here. What this would mean is we know a couple of things about this. We know that the height of this is y and the width of this is x. And these are the components, horizontal and vertical, for this vector u here. If I want to have the magnitude of u, then it is fair to say that it's really just using Pythagoras here. It would be the square root of x squared plus y squared, where these are just the components of this vector here. So we have the x component and the y component. So if I wanted to find the magnitude of PQ, first thing we're going to do here is we're going to say, well, the magnitude of PQ, we're going to write this here. So vector PQ is equal to the square root of, and then its components squared, summed, and then taken the square root of. So we'd say -1 and 5. So this is straightforward as this. You do this every time. We say 1 plus 25. So this would be root 26, which I do not think is something that we can simplify here. So we get, in this particular instance here, we get the magnitude of PQ. So the magnitude of PQ, or its length, is equal to the square root of 26, which is be a little bit over 5. So that is how long this vector is right here. We could even label this magnitude PQ. PQ. Try this again. It is root 26. So now we want to find its direction angle. Now recall that the direction angle is assuming that your vector is already in standard position or in component form. So we slid this vector here, PQ, down to start at the origin, but the direction angle is always starting at the positive x-axis and rotating counterclockwise some angle between 0 and 360, not including 360. So we notice we have some angle here, a direction angle, that is bigger than 90 degrees. I hope we all notice this, but in general, I'm going to go back down to here. We say, remember that the magnitude of, say, this vector u would be this. Well, the direction angle here, theta, could be obtained by saying, well, we know x and y, the vertical and horizontal components of this. And if you know the components, we could say that the tangent of this angle is equal to y over x. So again, we could say that this is always true. At least this is going to be theta prime or theta party hat here. This is our reference angle. But it'll just be the tangent inverse of our y value, or y component, over the x component of our vector. So that being said, then we could say this with all due fairness. Then we know that with this vector here, it terminates at -1, 5. And we already know its components. So if we wanted to have this direction angle, we're going to say that it's theta prime is equal to, I'm going to say equal to, tangent inverse of y component, which is 5, over x component, which is -1. So we're going to get our calculators out here, and we're going to ask it in degrees, what would this measurement be? So we have 5 over -1 is -5, so we get -5, and we'll do the tan inverse of this. And so we would get this -78.69 degrees. Now, one thing I want to bring up here is this. We said that it's a reference angle, and those are always positive. So technically, we should call this 78.69 degrees. But this 78.69 degrees, you have to draw a picture of this, because what that is, and if I could zoom in here a little bit here, you know, like here's our triangle that you're seeing right here. You're finding this angle right here, this 78.69. That's what that is. So what we need to do is we need to determine this angle out here, this theta, and we would say that it's really, if this is 78.69, what we could do is we could say, well, take that away from 90. I'm going to add 90 to this negative here. And this 11.3, this is this leftover angle right here, this 11.3-ish. So we could say that, you know, it's 90 plus 11.3, or we could even say it's 180 minus 78.69. So 101.31 degrees. 101.31 degrees is the direction angle of this particular vector. It's going in that direction. Okay, so we have the direction angle. So the very last thing we want to do is write PQ in linear combination form. So recall this, when we talk about linear combination form, we're saying that it's a bunch of i's being added together with a bunch of j's. So we say I, the vector I, or you can see I hat sometimes as 1, 0, and then j hat is this vector 0, 1, which basically these are standard unit vectors, but we said that every vector here, including the one we have up here, we could say it went left 1 and then up 5. We could really say that this is -1j vector, or it's going left 1 unit, and it's going up 5 units, so it's positive 5j units. So in general, we say given some vector in component form. If I know that x, y are the components, then we say that its linear combination form would be this. You know, we could say that it's xi plus yj. And you just use these as the coefficients for your number in component form. So that being said, we say, well, we already know the component form for this is -1, 5. So if we want to write this as a linear combination of standard unit vectors, it'd just be -1i plus 5j. And that's it. You could put little hats on them if you wanted to denote their vectors, or you put your little vector line. But basically, that is this last little portion right here. So we'll get into heavier stuff in the next video. Cheers.